Okay, what we're looking at is a Heathkit ig102 RF signal generator. This signal generator is a very popular one. Covers a wide range of radio frequencies starting at 100 kilocycles, winding up at 110 megacycles, and it does that in 6 ranges. Um, has an internal modulator that will produce a 400 hertz tone, or will accept an external modulating tone and will modulate the RF frequency with that. You have a you have the modulation control here for percent modulation, internal and external switch, your range switch. We have a 3-step attenuator, low, medium, and high attenuation, and a variable attenuator for in between each one. And then the vernier itself with all of the scales. So it's been modified. The original button type connectors, the old-fashioned Heath connectors looked like this. Have been replaced with the modern BNC connectors, and that way you'll be able to use all of the less expensive and easier to get modern connectors, which will connect to most of your modern equipment. So, taking care of that, the unit has been cleaned carefully, and as you can see, it's in fine condition. We have a couple of minor surface scratches off here on the left, which is unfortunate because otherwise the faceplate is in excellent condition. The cabinet has been repainted. Gave it a very good paint job. And it looks actually nearly new. I think you'll find it very pleasing. And then on top of that, we're in good operating condition, as we're going to prove now. So bear with me, we'll connect up and we'll give this thing a checkout. Alright, what I've done is I've connected myself up to this scope. I'm going to turn this light off so we have less interference here. And at the moment I am at 100 kilohertz, and I'm going in band A, which goes from 100 kilohertz to 320 kilohertz, and I'm going to progress forward through that band. Alright, I'm going to progress through this band, and I want you to watch the scope trace and look for abnormalities, anything that you don't like, as I progress. Okay, I'm going forward now. We're going mid-band right about now. Progressing to the upper range. Winding up at what should be 320 right here. And then we go to the next range. Let's drop ourselves back down. Alright, we're now on band B. We go 310 kilocycles to 1.1 megacycles. And here we go. Alright. I'm going to go ahead and step up that oscilloscope in a moment here so you can see more clearly. Alright, we just reached the top of that band. There. Drop ourselves back down. And we are pumping out right now something on the order of 50 millivolts per centimeter in, what are we doing? Roughly 4.5 centimeters, so 200 millivolts of output. That's a lot of output. We really could take it down, but let's go to the next range. We're at 1 megacycles to 3.2 megacycles, and this would be 1 right about here and progressing forward. That's mid-band there. And we're at 3.2 right about there. Make sure we're still centered. Yeah, we dropped it a little bit. There we go. And I think we're going to turn our attenuation down a little bit. Okay. Band D, 3.1 to 1.1 megacycles. We can take that back up again. About mid-range right about here. Okay, maybe come up in range again. This would be 10 megacycles to 32 megacycles. All right. Approaching mid-band here. Let's cut down that a little bit. We're getting a little more efficient. And there we are at 32 megacycles. Let's I'm at the maximum of my my scope at that point. Let's see. And then we go 32. All right. We are now on the last band. This is band F. And this goes from 32 megacycles to 110 megacycles. So we're at 32, progressing forward. This is the most sensitive band, obviously. That's mid-band about there. Quite efficient, even though we're at a high frequency here. At this point, we're at 20 millivolts per division, and we have darn near 8 divisions, so almost 160 millivolts. We're at 110 megacycles right now. So 110 megacycles, and the only thing I could do here would be to expand the scale, and there we can show you the 110 expanded times 10. So there we've gone through all of the ranges. We can see that the output's there, that it does what it should do. Let's get back down to something reasonable frequency wise. Okay. And we're going to turn on our modulator here. Now, right now we're in the external modulation mode, and what I'm going to do is I'm going to turn on the internal modulator. And there you can see the internal modulator. External, internal. External, internal. Yeah, let's go ahead and show that too then. We're going to go to the coarse attenuator. There's the first step, mid step, last step. As you can see, we do have the signal there, much greater signal, and then right off of the screen. Okay. All right, let's take a look at the vernier now and see about the accuracy of the vernier. Just how close are we? We're going to use a frequency counter to measure the frequency that the vernier gives us and determine whether or not it's accurate. Okay, that would be band A at 100 kilocycles. And then we are reading 100 kilocycles. So there's nothing wrong with that. Let's go to midband. Be about 170 kilocycles. Right there on the dial. And we are getting 170.9, so 171. We're at 1 kilocycle off, according to the vernier. Now if we went up to 320, excuse me. All right, that's 320 there. We see that we're setting at 315.6 or 316, so 4 kilocycles off at 320. The difference, if I was to get 320, I'd have to, let's see, let's just adjust this till we see 320. All right, there's 320, and I'd say we moved about 1/8 of an inch on the vernier. We got 320. Not bad, not bad at all. Let's go to band B, 310. That would start right about there. That would be 310. We're getting 308 out of the meter. Let's go to midband. That would be about 55, right about there. And we are getting 552 instead of 550. We're 2 kilocycles higher, minor. And then 110, right about there. We're getting about 107. All right, band C. One megacycle would be about here. And we're getting 971 on the counter. Midband about here. That'd be about 1.7 megacycles. We're getting 1.66, rounded up to 1.7, and then 3.2, right about there. Goes up 3.03, so 1.7 megacycles, 3.2, 3, yeah, let's try that again, 0.17 megacycles off. All right. So far, everything is really right there. 3.1 megacycles to 11. We're reading 3.09 for 3.1. This would be 5.5 megacycles, 5.54. Oops, go to 100, it's going to be 11. We're going to go to 11 megacycles, that would be right about here. And we've got 10.64, so right at 11. Band E. We want to start off at 10. There's 10, and we got 9.94. We're going to go up to mid-range, roughly it's 17 megacycles. We're getting 17.2. And let's go to 32 megacycles. And that would be it. And we're at 31.6, so 32. Finally, the last band. All right. this would be 35 on this range, and we are getting 35. Unfortunately, if I go below, I'm losing some amplitude. It's such that my the sensitivity of my counter won't handle it, which is disappointing. However, 35, we are right on the dial. And if we go forward, we're going up to 110, so let's see, mid-band would be about, yeah, let's call it 50. That's 50 megacycles, and we are reading 50.7. And if I go forward to 110, that would be about it right there. And that 110 is giving me 111. So in all cases, the accuracy of the dial is around 1 to 2%, and all of the functions are working. The unit is in nice clean shape, very nice looking. Well, as with all my units, I'll be providing this, or at least I try to make it with all my units. I'll be providing this with a brand new set of BNC to Gator clip test leads and a manual. This is the Heathkit assembly manual. Takes you through the assembly of the unit, gives you theory of operation, schematics, usage information, the whole shot. So, got everything, testing here, calibration, everything you need to know about the unit. It was originally taught to the person who put it together. And happy bidding. We'll see you again. Thanks.